Hello friends, I am Pratima. I welcome you over to my channel. I thank all the subscribers for supporting, and I am very happy that you like my videos and inspiring me with your comments. Today's very interesting question: how to prove for all positive integers n minus 1 is less than 1 over square root of 1 plus square root of 2 plus 3 over square root of 2 plus square root of 5 up to last term is square root twice n minus 1 over square root n minus 1 whole square plus 1 plus square root n square plus 1 less than n. So let us see the kth term. Kth term equals to 2 twice k minus 1 over square root k minus 1 whole square plus 1 square root k square plus 1. So first we'll rationalize the denominator. We'll twice k minus 1 square root of k minus 1 whole square plus 1, not this one. One moment please. So I'll rationalize in this way. First is k square plus 1, this is bigger, minus square root of k minus 1 whole square plus 1. Same thing I'll multiply in the denominator. K square plus 1 square root k minus 1 whole square plus 1, then square root of k square plus 1 minus square root of k minus 1 whole square plus 1. So the numerator will be as it is. Denominator will be simplified. That's why I made like that. So it will be k square plus 1 minus k minus 1 whole square, k minus k square plus minus 2 twice k plus 1 plus 1. It will be 2 twice k plus minus 1 k square plus 1 minus k minus 1 whole square plus 1 whole square root. Here this will be k square cancelled, 1 cancelled. We are getting 2k will be positive, 1 will be negative. So which will be cancelled with the one fraction of one part of the numerator. So ultimately we are getting kth term equals to k square plus 1 minus k minus 1 whole square plus 1. Then summation of the terms k equals to 1 to n k square plus 1 minus k minus 1 whole square plus 1. I divided the whole thing one term into two terms. Now we'll taking the telescopic sums. Series, that means we cannot write each and every term, but we'll imagine what will be the. So now when n equals to 1, this it will be square root 2 minus square root 1. When n equals to 2, it will be square root of 5. N equals to root 5 minus square root 2. When n equals to 3, it will be square root of 10 minus square root of 5. So if we go on writing the numbers, the sum will be your square root of 2 minus square root of 1 plus square root of 5 minus square root of 2 plus square root of 10 minus square root of 5. Last term will be square root of n square plus 1 minus n minus 1 whole square plus 1. So here these two are cancelled. First term of the first is cancelling with the second terms of the second. First term of the second is cancelled with the second term of the third. So now we can see through a telescope that last term will be cancelled with the first term of the last but one. So only this will be left, and here this will be left after the taking whole sum. So s equals to now square root n square plus 1 minus square root of 1 is 1. So this is the sum. Now the question is, we have to prove the sum is in between your n minus 1 to n for any positive integer of n. So n is positive integer. So we have to prove n minus 1 is less than square root of n square plus 1 minus 1 to n. First coming to left-hand inequality. N square is less than n square plus 1. So square root of n square, that is n, is less than equals to square root of n square plus 1. Subtracting 1 from all the sides, n minus 1 is less than equals to square root of n square plus 1 minus 1. So left-hand inequality proved. Then coming to right-hand inequality. Or n belongs to positive integer z, n plus 1 whole square is greater than n square plus 1. Or n plus 1 is greater than square root n square plus 1. Or n is greater than square root n square plus 1 minus n. So proved. Now combining inequality, we'll get n square plus 1 minus n is greater than n minus 1 and less than n. Proved. Thank you for watching.